Hello, 7th grade math. Today I'm going to demonstrate for you guys how to graph equations, linear equations, without making a table. All week long we've been practicing how to make a table, follow an equation, plot the points, and then make our line. But there is an easier way to make lines without having to make a table, and that's going to be the focus for today's lesson. So without any further hesitation, I'm going to go ahead and just jump right in. I'll begin up on the top left-hand corner up here with box number 1. I'll go ahead and start explaining what's going to happen. For number 1, we have the equation y equals 1/4 x minus 1. Typically, you make a table of x values, plug them into the equation, get a bunch of y values out, and plot the points. But right now, I'm going to show you the quick and easy method to graph a line. So first of all, let's look at the equation carefully. The equation is made up of 2 parts. You have a number with x. That's called our slope. And then we have another number that's attached. This right here, along with the sign that goes with it, plus or minus, is called our y-intercept. That means whenever we graph this line up here, it's going to cross the y-axis at a certain point. This number right here is that point. So I will go to -1 on the y-axis. Here's my y-axis. -1 is right here. So I will go ahead and plot my first point there. Well, as discussed in class, we also know that we need a minimum of 2 points to make a straight line. So the question then becomes, where's my second point? Well, to get that second point, you have to look at the number that's with the variable. In this case, the 1/4. This 1/4 tells me that to go from this point that I made to the next point, I will have to rise 1 square and then run or move over 4 squares. So what that would look like would be rise 1 over 4. 1, 2, 3, 4. And I'll plot my point. Rise 1, 1, 2, and then my other point would be somewhere off the grid. I can also work backwards. I can go back 4 and then down 1. And I can make sure the rule still fits. Rise 1, 1, 2, 3, 4. Rise 1, 1, 2, 3, 4. I now have enough points to make a straight line. So I'll take my straight edge and I'll go ahead and carefully line up all these points as best as I can and get them all on the same line. And bam, there I go. Quick and easy, pain-free, not a single problem there. Easy enough, I would hope. If not, let's go ahead and practice some more till we really get the hang of it. I'll move on over to our second equation over here. This equation says y equals -x plus 2. Well, when you have -x, that really means y equals -1 times x plus 2. So to use the same method I did before, I will first identify my y-intercept. The y-intercept is this plus 2. So I go to the y-axis, I go to 0, and positive 2 on the y-axis means 2 squares above 0. So that's where I place my first point. Now I look at my slope, which is -1. Well, -1 needs to be written as a ratio or fraction. The best way to make any number into a fraction is just to put it over 1. That means instead of rising, which I typically would do, negative means then I will be going down 1. This plus 1 means that when I move, I will still keep going in the positive direction 1 square. So starting from this point, -1 means I go down 1 over 1, down 1 over 1. And I can repeat this process until I have enough points to fill my graph or my grid up. I can also work backwards because I can see they all line up in the exact same location. Now I take my straight edge and I line it up as best as I can in order to get all the points covered, and I draw my line. And yours should look pretty good because yours is on paper and not done electronically as mine is. So there's our first 2 graphs. But I'm suspecting some of you may still not be too sure. So I'll go ahead and try some more examples with you. I'm going to go ahead and delete what I have on the screen and then move my page up. So let me go ahead and do that now. Let me clear my screen up. Then I will go ahead and try to move up just a smidge. Let me go ahead and get this a little more controlled. There we go. So let's go ahead and go to 3 and 4. All right, so for 3 and 4, the same process happens over again. Now, I need to identify my y-intercept, which is at positive 1. So I go to my y-axis and I find positive 1. Here's 0. Positive 1 means 1 square up. Now, I don't see a number in front of my x. But how many x's are there here? Well, there is really 1x. So my slope is 1, make it a fraction, over 1. That means I will rise 1 square, and then I will run to the right 1 square. So up 1, over 1, up 1, over 1, up 1, over 1, up 1, over 1, so on and so forth. I could even backtrack and get some of my other previous points using the same method. And then now I will go ahead and take my straight edge, and I will line up all my points as best as I can, and then connect them all. And there I go. There's my line. Now, what's really happening here is I'm going to go ahead and erase what I wrote up here, and I want to break down what we see happening so you know how to verify that you did the right line. My line crosses here at positive 1. That's exactly what I see right here. To go from one point to the next point, I go up 1 over 1, up 1 over 1. That means I have a slope of 1, which is the invisible number we don't see, but really is right there. So that's how we handled that type of example. Let me fix this little arrow tip there. It's getting on my nerves. Now, let's move on over to example number 4. In example number 4, we have a y-intercept of negative 4. So I go to 0 on my y-axis. Negative 4 means I'll go down 1, 2, 3, 4 boxes, and then I plot a point right here on the y-axis. And then I look at my slope. It's 4/3. 4/3 means I'm going to rise 4 squares, and then I'm going to run to the right 3 squares. So it's up 1, 2, 3, 4, 1, 2, 3, plot a point. 1, 2, 3, 4, 1, 2, 3, plot a point. I have enough points now to make a line, because all you really need are 2 good ones, but it doesn't hurt to have some more. And then I'm going to go ahead now and connect my dots. And there we go. We've drawn 2 more, we've created another line, and we've collectively done 2 more examples. Not too bad, I hope. But just in case there's still some speculation, I'm going to go ahead and scroll to the next 2 examples. At this point, if you want to, go ahead and on your boards or scratch paper or graph paper, go ahead and try graphing the next 2, and then you can watch me to see if you know, if you wanted to check if you're doing it correctly. I'm going to go ahead at this point and go right in to those next ones. So let me go ahead and clear my screen and go ahead and move it down. So here's 5 and 6. 5 and 6 are pretty straightforward. 6 is interesting, and I'll get to that one in just a moment, but let's go ahead and work on 5. On your own, if you feel comfortable, go ahead and work on number 5, and then start the video again, or pause the video now, work on number 5, and then when you've completed it, go ahead and continue the video so you can see if you did it right. Let me go and explain now how we're going to graph number 5 using the same method as before. So this time, let me identify my y-intercept. It is negative 3. So I go to the y-axis, and I will go to negative 3 on the y-axis, which means 3 squares below 0. There's my first point. My slope is negative 3, but I need to make it into a fraction, so I just put it over 1. So that means instead of a rise, I will be falling down 3 units, and then I will be moving to the right 1. So it's going to be down 3, and then to the right 1. Well, I kind of want more points. I know to go from this point to the previous one, I would go left and then up 3. So I'm going to do the same thing to get the previous point, and maybe even a few more. And now I have enough points to make a line. So I will get my straight edge, just like I did before, and I will make a line to connect all these points. And there I go. Easy enough. Now we come to this special case. This one says we want to make a line wherever y equals 4. All right, so here's my y. Where's 4? Well, it's a positive 4, so it's going to be up here. So I put a dot right there at y equals 4. Now, it doesn't tell me to do anything else. It just wants me to put or make a line wherever y is 4. Well, the coordinates here are 0, 4. That's where I'm at right now. But is that the only point that has a 4? No, I can go right here to 1, 4. That has a 4. 2, 4. That has a 4. 3, 4. That has a 4. So basically what I'm getting is this horizontal line wherever y is equal to 4. So it doesn't matter what x value I put in. It could be 1, 2, 3, 4, 5, or 6. It doesn't matter what number I have on the x. My y will always be up here at 4. So this is one of those special cases where you get a flat horizontal line. You connect all your points, and there you go. So based on this example, what if, just what if I had this equation, x equals 4? Can anybody tell me where they think or how I would graph that and how I would make it look if it was to be graphed? I'm going to pose this question, and I will offer bonus points to anybody who responds on Google Classroom and can verbally explain to me what they think this graph will look like. After this video is done, you'll receive an assignment. If at this point you still need some help, please raise your hand, and one of us will be over to help you. Thank you so much, and good luck on your assignment, guys.